Today we're going to talk about the conjugate pairs theorem, and we need to remember what conjugate is, first of all. And in general, what I like to say is, with a conjugate, we change one sign of the binomial. But it's not always a binomial, so I can shorten that saying and just say that we change one sign. So in the case of the conjugate pairs theorem, if we're given a polynomial, and one of the roots of the polynomial is a plus bi, then its conjugate is a minus bi. We changed one sign. It was plus bi originally, and then it became minus bi also. And there's one other thing that we need to know, because until you really see the conjugate pairs theorem work, I don't think that's going to stick in your head. But what does the square root of -1 equal? It equals I. And we didn't talk about it. We kept it really, really basic in terms of I this year. But we actually can figure out what I squared is. And there's an involved explanation for it. But I squared equals -1. And if you want the long involved explanation, we need to do that, just you and me. But I'm even going to highlight this because we're going to need to use that. So I squared is -1. And what I try to tell all of the classes is, if you can say it out loud a lot of times, then you can remember it better. But if you're not one of those say it out loud kind of people, at least say it in your mind, because I'm going to ask you on many questions today, what does I squared equal? And then you're going to tell me it equals -1. And probably only one or two of you are going to tell me. But, again, at least say it in your mind so that you remember for the test next week. So, first of all, let's, again, talk about the conjugate pairs theorem. And it says, given the degree of the polynomial and information on some of the roots, state the missing roots. Well, something that we need to know is, if the degree is 4, how many roots do we have? We still have 4. So if we look up here in our problem, we have 4i, there's one root. We have 3, there's a second root. There's -8, there's a third root. What's the fourth root? Well, it's the conjugate pairs theorem. We have 4i. So our fourth root is, we change one sign, we have -4i. So if we look at the second one, degree 3, well, degree 3 means that we're going to have 3 roots. One of the roots is I times the square root of 11. One of the roots is 6. What's our other root then, our third root? -I times the square root of 11. And finally here, degree 4. Once again, the degree determines how many roots there are. The difference today is we're not just looking at real roots, we're looking at imaginary roots. But we have 4 of them. And we have listed 2. 5 plus I and -I radical 3. Well, 5 plus I, what's its conjugate? 5 minus I. There's a third root. We have -I times the square root of 3. What's the conjugate? +I, square root of 3. 5 plus I is one root. -I radical 3 is the second root. 5 minus I is the third root. +I radical 3 is the fourth root. So we're getting into the imaginary roots now. But what we really want to do is we want to use our skills from earlier this week to write a polynomial of least degree. What? I radical 3. So we want to write the polynomial of least degree, which means that we're just going to create a polynomial with the lowest degree. We could have more roots, but this is all that we can see right here. So we're starting out with problem number 4. We know that a root is 5, Our root is 2i. Do we have a missing root that we can identify? Negative 2i. Well, we're going to do the same exact thing that we did earlier this week. So again, if you were absent earlier this week, you could really use this concept to learn what you missed earlier this week. So the first root is 5. You could say x equals 5. The second root is x equals 2i. And then we found our missing root, and we can say x equals negative 2i. So what we do then is we can subtract 5 from both sides, and we get x minus 5. We can do the same thing with 2i. We can move it to the other side. We can subtract 2i from both sides, and we get x minus 2i. And then we have x equals negative 2i, so we can add 2i. So we're going to get x plus 2i. And we're going to multiply all these together. The one thing that I can recommend on this particular problem is because we have conjugates here, x minus 2i and x plus 2i, we changed one sign, is I recommend that you multiply these two together first. You don't have to, but it will be a little bit easier. So when we multiply, they don't cancel each other out, but x times x is x squared. X times positive 2i is positive 2ix. Negative 2i times x is negative 2ix. And negative 2i times positive 2i is negative 4i squared. 2 times 2 is 4. I times I is I squared. Well, like I said, they don't cancel each other out, but something does cancel out in them. And that's the 2ix and the minus 2ix. Those are opposites. They cancel each other out. And what we're left with is we're left with x squared minus 4i squared. But what does I squared equal? Negative 1. I would like, again, to recommend that the more you say negative 1 equals I squared, the more you're likely to remember. But when we simplify this part of the problem then, we're going to be left with x squared. Negative 4 times negative 1 is positive 4. And we still have, off here to the right, we didn't touch that value yet. We still have our x minus 5. And this should look very, very familiar in comparison to what we did on the earlier lesson this week. So now we've got our blue binomial that we can multiply through, and that eventually is going to lead us to our standard form and able to answer our other questions. And it's x times x squared, which is x cubed. X times 4 is 4x. Negative 5 times x squared is negative 5x squared. And negative 5 times positive 4 is negative 20. First, outer, inner, last. Now, it's not in standard form, but we can put it in standard form when we write it up here. X cubed is our highest degree term. And then it's going to be minus 5x squared. That's our next highest exponent. Then our next highest exponent is plus 4x. 3, 2, 1. And then our minus 20 is our constant value. Standard form. What's the degree? 3. What do we call a third degree polynomial? Cubic. Maximum number of turning points. 2. 1 less than the degree. And here's the thing, once again. If you cannot look at the equation and go, oh, the end behavior is this, what we're going to do is we're going to look at this on the calculator. And I know I've got some equations in the calculator, but x cubed minus 5x squared plus 4x minus 20, there's our answer. Let's look at the picture. Now, in this particular case, we cannot see the entire picture. We can see to the left, it looks like we're going up to positive infinity. Sorry, to the right, we're going up to positive infinity. But we can't see the whole picture. Zoom and scroll down to 0. And you can just type in 0. And what that's going to do is that's going to give us a picture of the polynomial. And now we definitely can see. As x goes to negative infinity, as we go to the left direction, we're going downward. As x goes to the right, we're going upward. And downward is to the negative infinity. And the up is to the positive infinity. And there's no reason that you should miss those problems when you can type them in your calculator. I mean, we can look at the leading coefficients. That's how I can do it quickly, because I look at the leading coefficients. But use the calculator. Why not? But that's what we did earlier this week. I want to take a look at problem number 5, and I would like to show you a shortcut that works. And I use the term shortcut loosely, because it's still going to be a long problem. And what we've got here is the root is 6 plus 3i. Do we have any other roots that we can identify? So it's going to be 6 minus 3i. Again, I'm going to use a shortcut. It's not the only way, but it is much shorter than the other way. If you would like to see the other way, it just needs to be you and me. Well, this is what we're going to do. We're going to say x equals 6 plus or minus 3i. The only difference there is the sign. Our ultimate goal is to write the polynomial in standard form. But in order to do that, we need to isolate the plus or minus. That's the issue in this problem. So to isolate the plus or minus, we're going to subtract 6 from both sides. And we get x minus 6 is plus or minus 3i. Well, again, the issue in this problem is the plus or minus. What we need to do is we need to figure out how are we going to get rid of that plus or minus. Well, the way that we're going to get rid of the plus or minus is we're going to square both sides of the equation. So if we think about it for a minute, what's positive times positive equal? It equals positive. What's negative times negative equal? Positive. And because no matter whether we square a positive or we square a negative, we come up with a positive value. When we square this, the plus or minus cancels out. So over here, remember, squared means times itself. And we cancel out the plus or minus, and we still have multiplied by itself. And now we have it in a format to get our polynomial eventually into standard form. We're going to have to FOIL the left side. X times x is x squared. X times negative 6. Negative 6 times x. And negative 6 times negative 6 is positive 36. Over here on the right side, 3i times 3i. 3 times 3 is 9. I times I is I squared. Yes, you're one step ahead of me. So if we simplify over here on the left, we get x squared minus 12x because negative 6x and negative 6x added together plus 36. And again, it's 9i squared. What does I squared equal? Negative 1. And the more you can say it, the better chance you have at remembering it. So we're almost done now. And I know, it doesn't seem like it's a shortcut, but believe me, it's a shortcut. X squared minus 12x plus 36 equals negative 9. And finally then, we can move the negative 9 over to the other side, and it will, our equation will be even in standard form. We don't have to do anything extra. It's x squared minus 12x plus 45. There's our standard form. So we'll go back to our blanks here. I can make this one a little bit bigger. But once again, and I should probably a little bit more technical say it's y equals x squared minus 12x plus 45. What's the degree of this function? It's 2. And what do we call it? Taryn, say again. It's quadratic. Something to the second power is quadratic. Maximum number of turning points? 1. And again, if you don't know what the end behavior is, we can go back to our graph here, and we can graph it. And you won't be able to see very much, but you can see enough. It's pretty small up there. But what we see as we go to the left, we're going up. As we go to the right, we're going up. Up means we're going up to infinity. So here's our infinity. Notice, we had 2 imaginary roots. Our graph does not cross the x-axis. That's an example. This picture here, even though it's weak, does not cross the x-axis. 0 roots, 0 real roots. Now, we've been applying the conjugate pairs theorem to the i's, which we'll continue to do, but the fact that there's a radical in here doesn't change the conjugate pairs theorem. We have negative I times the square root of 7, we've got 4, we've got 0. What's our missing root, if any? Well, our missing root is positive. Positive I times the square root of 7. So when we set this up, very, very similar to what we did on Tuesday, if not the same. In fact, when we set it up, I do set it up the same. X equals negative I radical 7. X equals positive I radical 7. X equals 4. X equals 0. But I would like to show you how to do that shortcut again, because it does work when there's a radical in the problem. And what we do with that is we can say x equals plus or minus I radical 7. The good news on this problem is the plus or minus is isolated already. So we can square both sides. We need to be a little bit careful. But over here on the left side, we get x squared. The plus or minus cancels out when we square, because everything's going to turn positive. But this is I square root of 7 and I square root of 7. Squared means times itself. So when we multiply, we get x squared equals I squared, I times I. Square root of 7 times square root of 7, square root of 49. And I think that Mr. Jarvis didn't show you that step. And I'm fine with that. You don't need to have that step, but I don't want to omit that. he might have said, well, look, you've got two of the same value, pointing at the square root of 7. Square root of 7 times square root of 7 is simply 7, which also happens to be the same thing as the square root of 49. Now, I wish that I would have filled in, what does I squared equal? It equals -1. So here's our -1 times our 7. So what we have close here with this lilac, pinkish, purplish, whatever color you want to call this, we get x squared equals -7. And then we're going to move that -7 over to the other side. We get x squared plus 7. I'll scroll back down in a moment. But if you notice on the problem, if you feel comfortable, I still have two blue numbers that we need to deal with. It's a lot quicker with just the real numbers. But we finished with the x squared plus 7 there. But again, over here I've got x equals 4 and x equals 0. We can subtract 4 on both sides. And that is exactly what we did earlier this week. And we can subtract 0 from both sides. But do we really need to write -0? No. This is x minus 4 times x. So what we're going to do then is we're going to distribute the x. And we end up with x squared minus 4x. And now that we've done that, we need to take our x squared plus 7 and we need to multiply it by our x squared minus 4x to come up with our polynomial in standard form. And we're using a distributive property, which I use the method of FOIL. First, outer, inner, last. The x squared gets distributed over to the blue parentheses. The 7 gets distributed over to the blue parentheses. And when we multiply, x squared times x squared is x to the 4th. X squared times -4x is -4x cubed. 7 times x squared is 7x squared. And 7 times -4x is -28x. And it's nice because it ended up in standard form already. We just need to put it back in the box there in a moment. Some people are still writing. So we've got x to the 4th minus 4x cubed plus 7x squared plus 7x squared minus 28x. And that might look familiar to you from your quiz earlier. But what's our degree? 4. And again, what do we call a 4th degree polynomial? Quartic. What's our maximum number of turning points? 3. And again, if you cannot look here and go positive infinity, then what we're going to do is we're going to look at it on our calculator. So we type it in. And there's the picture. Can't see it very well. We can do the zoom 0 if you don't like that. And then we can see it well enough. And we can see it pretty darn good, actually. Because as we go towards negative infinity, as we go towards the left of the graph, we're going upward, which is to positive infinity. As we go, x approaches positive infinity, which is going right on the graph. We seem to be going upward again, which is approaching positive infinity, which is exactly what we just wrote down. If you can look at it, if you're wondering how I can do that so fast, it's because I'm looking at the leading coefficient. The leading coefficient is positive, even degree. We're either going to go to positive infinity, or to negative infinity. They go in the same direction. But lastly, to finish here on our notes. First question. What are our missing roots, if any? We don't have any missing roots on this one. We don't have any i's in there. And then we've got our radical 3's. So when we set this up, we've got x equals 2, and x equals the square root of 3, and x equals negative the square root of 3. We can use the shortcut on the square roots, on the radicals, which I'm going to do. You don't have to, but this means x equals plus or minus the square root of 3. These two together, here's positive, here's negative. So what we can do then is we can square both sides. And squaring both sides means that our polynomial part there on the right is always going to be positive. So we get x squared equals square root of 3 times square root of 3. And again, Mr. Jarvis might not have done this step, but I like to do it. That's x squared equals square root of 9. And what does the square root of 9 equal? 3. 2 of the same take out 1. And my dot there didn't show up, so I'm going to put parentheses back in there. My dot didn't show up very well. So we get x squared equals 3. And then we can subtract the 3 from both sides. But there was one more part to this problem. X equals 2. So let's subtract 2 from both sides. We get x minus 2. And then we're going to multiply that x minus 2 times the value that we just got. So we FOIL. X cubed minus 3x minus 2x squared. Negative 2 times negative 3 is positive 6. It's not quite in standard form, but we can put it in standard form. You're welcome. So we get to here, x cubed minus 3x minus 2x squared plus 6. Once again, we need to put that back into standard form. X cubed minus 2x squared minus 3x plus 6. What's the degree of our polynomial? 3. Maximum number of turning points? 1 less than the degree. And again, if you cannot look at this and say, this is negative infinity. As x approaches negative infinity, y approaches negative infinity. As x approaches infinity, y approaches positive infinity. Then we'll finish by typing it in our calculator. So luckily I have it typed in already. And we can see it pretty well. As we go to the left of the graph, we're going in the downward direction, which is towards negative infinity. As we go to the right of the graph, our graph is going upward, which is towards positive infinity, which hopefully is exactly what I wrote. And it is. Hopefully.